Thank you for participating in the demonstration of the Financial Digital Twin, a framework to support decision-making and internal controls in public capital projects. Public sector organizations plan for the maintenance, rehabilitation, and construction of needed facilities on an ongoing basis, and typically, while seeking to make the highest and best use of available funding, the public facility owner still needs to remain in compliance with the regulations of multiple funding sources, such as federal, state, local, and debt funding, often with varying and potentially conflicting distribution, timing, and reporting regulations. Findings from literature and case investigations show that the feasibility planning and subsequent review of public sector capital projects typically occur in a siloed fashion, often resulting in inadequate information or inaccurate allocation at final project review, which in turn leads to final project approval delays pending the requisite corrections. Furthermore, minimal levels of fund allocation task digitization and integration into the project acquisition workflow result in excessive manual effort and duplication of work during cross-departmental data transfer. Therefore, the use of advanced integrated tools for the quick, accurate, and optimal allocation and monitoring of funds can provide support to address this. The digital twin is one such tool for facility lifecycle integration. It can be defined as a set of virtual information constructs that fully describes a potential or actual physical entity, and that at its optimum, any information that could be obtained from inspecting the physical entity can be obtained from its digital twin. It consists of three foundational elements: the existing or planned physical entity, its virtual representation, and the connections for bidirectional information flow between the two. Industrial use of the digital twin was piloted by NASA and the aerospace industry for real-time monitoring of remote assets, and in the last decade, industrial use of the digital twin concept has proliferated. The incremental development of a digital twin in tandem with the facility it represents give it the power for lifecycle integration of all facility-related information. Different types of data are created throughout the life of the facility, and different information management frameworks are used to collect, process, share, and use that data to perform various business functions across that life cycle. This research developed the Financial Digital Twin framework to support the creation, collection, processing, and sharing of funding source data for use in planning, allocating, and monitoring multiple funding source use in compliance with regulations. There are 5 basic parts to the Financial Digital Twin framework. It begins with the preparation of funding rules. The development of a classification system to map project and cost types to the funding sources they are eligible for is completed. Early collaboration between planning and finance guides the identification of available and allocable funding. A template to guide fund allocation is created for the allocator tool to reference. This will help in automating initial allocation as well as change management. The second part is to prepare an early phase, comprehensive building information model that accurately represents the planned or existing facility, and to integrate cost and schedule estimate information into it. The next part is the operation of the framework through the allocation tool. The fourth part is the representation of the results of the automated allocation, while the fifth part consists of the monitoring of the funding plan through the incrementally developed digital twin throughout project acquisition. This section reviews several scenarios demonstrating operation of the Financial Digital Twin prototype system. The tool offers 4 options: for allocation, fund plan updating, a quick summary, and a reset function. Selecting the quick summary shows that no funding has been allocated to this project yet. Selecting model elements also shows an empty funding source parameter in the highlighted element properties panel. In the first scenario, deploying the allocation function prompts the user to upload the relevant funding rules form. This is the template developed with construction finance in step 1 of the framework to guide compliant funding. Checks and balances built into the tool ensure that all model elements contain the requisite data, such as an estimated cost associated with them prior to allocation. Once the allocation task is complete, the tool displays the total amount allocated along with the number of funding sources used for the project. In addition, a color code of the fund allocation is applied to the model. And now, selecting any element reveals its newly allocated funding source. A look at the quick summary now also displays information about each funding source allocated, including the amount and percent of the project allocated and any additional requirements for using that source, such as small business participation and domestic procurement requirements. All this information is now embedded in the model and can be monitored for compliance throughout construction. In the second scenario, the update funding function enables the updating of an input form with additions or removals of funding sources, changes in amounts, and funding source ranking. The input template includes strategic level information for how funding sources can be ranked to maximize external funding and minimize the use of local cash resources. An example of change management and funding availability includes the provision of unexpected funding sources with time restrictions during the course of the project. Adding the new funding source in the input form enables the tool to reallocate the funding, taking into account all sources, including the newly allocated source. The quick summary highlights the changes in allocation with less sources used as the new funding has been allocated first, freeing up previously used sources. Finally, the Reset All Allocation function enables the removal of all funding source allocation to the project, as can be seen by the disappearance of the funding colors. A digital twin platform supports the building of a standalone visualization of the virtual twin of the facility to enable the visual analysis and review of planning and design concepts, but decision-making by multidisciplinary teams, many of whom may not interact with BIM authoring tools directly. In this third scenario shown, the digital twin platform has been enhanced with the funding allocation information to aid the review process by providing a comprehensive project description and visualization. The 3 custom buttons show the funding plan by highlighting the color-coded model elements along with the legend for the allocated funding sources. Toggling the quick summary shows the funding allocation details for review and decision support. The last scenario shows the interaction of a third-party application, such as Microsoft Excel, with the live virtual model data. In this example, the template has been created and linked to specific model information, namely the construction tasks, their duration, as well as the total cost of each task and the funding sources allocated to it. The template is pre-programmed to visualize the planned incremental use of each funding source on a monthly basis for each funding source and so support the planning and budgeting of each throughout project acquisition. Because it is linked to the live data of the digital twin, any changes to the cost, schedule, or funding sources in the digital twin can be updated with the click of a button to support the automation of this task. The template can be reused for all projects using multiple funding sources to be planned, tracked, and monitored. Thank you for participating in the demonstration of the Financial Digital Twin Framework and Prototype System operation.